Atoms, molecules, and ions. Atoms is the smallest particle of an element that can take part in chemical reaction. We need to remember the fact that if we see a chemical symbol, it represents one atom of the element. For example, take note that the chemical symbol for iron, in which we know before, iron, the chemical symbol is what is Fe. This Fe represents what? One atom of iron. This represents one atom of iron. Look at chromium, for example. The chemical symbol of chromium is Cr, and that represents what? One atom of what? Of chromium. And that's how we represent what? Atoms. Now, looking at this, if I have Na, what will you tell me? You say Na represents what? One atom of, of sodium. Take note, any chemical symbol you know represents one atom of the element. Now, we know this already. So let's quickly go to something that is very, very vital, which is called the representation of atoms. Consider this. Now, take note. Whenever you see this X represents the atom, if you see this superscript and this subscript, the one at the top means the what? The mass number. While the one below means the atomic number. And guys, take note of something, that atomic number also means the number of what? The number of protons. And the mass number is referred to as what? The mass number is referred to as the number of nucleons. Take note, whenever you are asked to get the number of nucleons, take note that they are talking about the mass number. The atomic number is exactly equal to the number of what? Of protons. Take note of some facts. If I have a neutral atom, we take note that what? The number of protons will be equal to the number of what? Electrons. Take note of this fact. And how do we calculate mass number? Take note that mass number A is equal to the number of protons plus the number of neutrons. Let me remind us of a fact. Observe this. Now, this is the structure of an atom. Take note of a fact that you see the center of this atom is called the nucleus of the atom. This is called the nucleus of the atom. Now, around the shell of the atom, we have the what? We have the electrons. We have the electrons around the shell of the atoms, like that. And take note that inside the nucleus, we have two subatomic particles present inside the nucleus. And those are the proton and the what? And the neutron. Good. These are the two subatomic particles you will see inside the nucleus. Now, if you are asked to calculate mass number, we say mass number is equals to number of proton, which is here, and number of neutron, which is here. Now, because proton and neutron are found in the nucleus of the atom, they are collectively called the nucleons. Are we together? Protons and neutrons are collectively called what? Nucleons, or nuclear particles, because they are found inside the what? The nucleus. And that's why we call the mass number the nucleon number, because it's as a result of the addition of the nucleons. That's that about that. Let's look at molecules. Take note that the combination of atoms gives molecules. For example, if I give you something like this, O2, which is what? One oxygen molecule. If you observe, in this oxygen molecule, I have two atoms of oxygen, O plus O. we can observe two atoms of oxygen gives one molecule of oxygen. If I have O3, this O3 is called ozone. How many atoms of oxygen do I have there? I have just three atoms of what? Of oxygen. You can see when atoms combine together, they give what? A molecule. Similarly, if I have F2, two atoms of fluorine comes together to give me what? One molecule of fluorine. So it means that in one molecule of fluorine, I have what? Two atoms of fluorine, and that is it. And take note that the number of atoms in one molecule is what we call what? Atomicity. Atomicity. If I say, what is the atomicity of ozone? It means that how many atoms do we have in ozone? We just have three atoms. What is the atomicity of fluorine? F2 is 2, and that is it. So the one that's having two atoms is said to be diatomic. The one that's having three atoms is said to be what? Triatomic. Why more than three? Like sulfur, S8, phosphorus, P5, all these are what? Polyatomic. All right, that's that about that. Now, the last thing we'll be looking at is what is ions. You see, ions are atoms or groups of atoms carrying a charge. Atoms or groups of atoms carrying a charge. The charge can be positive or it can be what? Negative. And that leads us to what? Two types of what? Of ions. We have the positive ions, which are called the cations. And we have the negative ions, which are called the what? The anions. These are the positive and these are the what? Are the negative. Let me give you examples of what? Of cations. We have Ca2 plus, Fe2 plus. Are we together? We have many of them. Na plus, we have K plus, we have Cr3 plus, and so on like that. Also, we can also have something like this, NH4 plus. All these are cations. Okay, you can see. Now, do you observe that in these atoms listed here, in these ions listed here, you observe that I only have one atom of the ion. Therefore, all the ions that fall under this category, we call them what? Monoatomic ions. It makes sense. Mono means one, atomic, then ions. Okay? So why this one? You can see that what? It has more than one atom. So I call it what? Polyatomic ion. And that is it. Now let's go to the anions. Now for the anions, what do we have? Observe. For the anions, we have S2 minus, Cl minus, we have O2 minus, and so on like that. Also, we can have the polyatomic ones as CO3, 2 minus, SO4, 2 minus, um, we have MnO4 minus, and so on like that. So you can see that what all these have only one atom, one S, one Cl, one O. So all these one they are what? They are monoatomic ion. These are monoatomic ion. Why these are what? They are what? Polyatomic ion. And that's the basic concept of it. All right. Let's look at ions in detail. Let's focus on the monoatomic ion. Whenever you come across something like this, for example, you have Al3 plus. What does it mean? Take note. If you have positive sign, it means losing. If you have negative sign, it means gaining. This shows that aluminium has what? Has lost 3 electrons. That's lost 3 electrons. That is the meaning. While if I have something like this, Cl minus. If you see negative, it means gain. It has what? Gained what? Gained 1 electron. Take note of this fact. And take note that what? Whenever we want to lose or gain something, we always attribute that to electrons only. We are not gaining protons, we are not gaining neutrons. It means that no matter the charge you have here, proton and neutron remains the same. Electron is the one that change because it's the one that you can lose or gain. Now, let's look at an example. Still using this. If I have something like this, Al3 plus, and you were given the atomic number to be 13. If I ask you that you should give me the number of proton, the number of electron, and the number of neutron for this, what will you give me? Firstly, like I said earlier, take note that uh, protons are not always lost. Here I have the atomic number to be 13. It's the same thing as what number of protons, so I'll have 13. And what will be the number of electron? Take note of something. If I just have something like this, a neutral atom, the number of proton here and the number of electron here are equal. Proton is 13, electron is 13 in this scenario. But here, 3 plus shows that it's losing 3 electron. That shows that what? You are going to have 13 minus 3, and that will give me 10 electrons. This is for 13 proton. And how do we get the number of neutron? If they want to get the neutron, they'll actually give you the mass number. And I'll give you that to be 27. So take note that, remember I told us that the mass number A, I told us the mass number A is equals to the number of protons plus the number of neutrons. So to get number of neutrons here now, I will say the mass number minus the number of proton. And that will give me what? 27 minus what's the number of proton? 13. And that will give me what? That will give me 14 neutron. And that is it. The major thing here is to find the proton and what? An electron. Let's look at another example. Observe this. If I have Ca2 plus and I have something like this. Here you have to find the number of protons, the number of electrons, and the number of neutrons. Remember, proton does not change. You still have it as 20. Remember that if this was a neutral atom like Ca2040, if this was a neutral atom, you still have your electron to be 20, just as the proton. But here, 2 plus shows that it has lost 2 electrons, so you have 20 minus 2, and you have what? 18 electrons. And what is the neutron? Mass number minus the number of what? Proton. So mass number 40 minus the number of proton 20, and that will give me 20. As simple as that. Let's go to the negative ones. Observe this. Starting with this, chlorine, Cl17 minus, and let me give you this to be 35.5. Looking at this, let me give you this as 35. Good. Looking at this, what's the number of proton, number of electron, and number of neutron? Proton doesn't change, 17. Remember, my electron should be 17 if they are neutral, if it is neutral, but it's not neutral. Minus 1 shows that it's gaining 1 electron. So you add 1 here, and that is what? 18 electron. And number of neutron, this minus this. And that's 35 minus 17. And you get your what? Your final answer. So you get that to be 18. Let's look at another one. If I have n, okay, let me put that another color. If I have n3 minus, and I'm giving this to be 7, I'm giving this to be 14. What number of proton, what number of electron, what number of neutrons? Proton doesn't change, so you have 7. You have your electron to be what? 7 plus 3 is gaining, and that'll give me 10 electrons. And your neutron is this minus this. So what's 14 minus 7? That'll give me 7. So as simple as that. So this is the basic concept of atoms, molecules, and ions. Let's look at the following practice problem. A particle that contains 8 proton, 9 neutron, and 9 electron could be written as. Now, we have the number of protons to be equal to 8, the number of neutrons to be equal to what? 9, and the number of electrons to be equal to what? To be equal to 9. Please take note of something. You will observe that I have 8 protons and I have 9 electrons. Since these numbers are not equal, it shows that the particle will never be neutral. If it is neutral, the number of proton and number of electron will be the same. But they are not neutral. If you observe, this particle gain one more electron. If you observe, normally if they are equal, the electron should be 8. But what happened? It gain one more electron to be 9. Therefore, let me say the particle is particle what? Particle X. Let me say the particle we are talking about, let it be what? Be X. Now, remember that any number that will be below when we want to represent atom will be the what? Number of proton or the atomic number. And if you observe, number of proton here is what? Is 8. Now, the number that will be here will be the mass number. And what will be the mass number? Remember that the mass number is equals to number of protons plus number of what? Plus number of neutrons. And that will give me what? 8 plus 9. And that will give me 17. And that's the mass number. All these are not affected. But this particle will surely have a charge. If you leave your answer this way, you are wrong. And what is the charge? Check it out. It gained one more electron. Because this electron is greater than this proton by 1, it shows that it gained what? One more electron. And that will be what? Minus. It makes sense. Let's go. If you look at it from here, your proton is 8. And your electron is what? Remember, 8 minus means gain. And that's what? 9. Which makes sense with the number of what? Electron. And this is how you can represent the particle. Okay, next question. The mass of an element is 27. Let me say I have the mass number to be 27. And the atomic number, and I can replace it as number of proton, and that is 13. What is the composition of the nucleus of the atom? Remember that if I have an atom, for example, inside the nucleus, I have the number of proton and the number of what? Neutron. So they are telling that what is the composition of the nucleus of the atom? It means that what is the number of proton and what is the number of neutron? Take a look. You observe that the question gave you atomic number to be 13. Then we write that to be 13. Let me see. I have atomic number to be 13. To be equal to 13. And for us to find the composition of the nucleus means tell me everything inside the nucleus. That is, I'm to get the number of proton and number of neutron. Remember, number of proton is always equal to the atomic number, and that's 13. And what will be the number of neutron? Remember, mass number equal number of proton plus number of what? Neutron. So, to get number of neutron, that will be what? Mass number minus number of proton. So, my number of neutron will be equal to what? Mass number, which is 27, minus number of proton, and that is what? 13. And this will give me what? This will give me 14. And that's the composition of. So the composition of the nucleus, this is what you present as your final answer. Next question. A non-metallic ion, Y3 minus, contains 36 electrons. How many protons are there in this what ion? See what we have. Y3 minus, and we're told that the number of electrons here is what? Is 36. Now, we were told that this ion has electron of what? 36. Did you know one thing? The thing is that I don't know the number of proton. Normally, if this atom is neutral, you will have the number of proton to be equal to the number of what? To be equal to the number of electron. Now, it is not neutral. It is gaining 3 electron. Now, since it's gained 3 electron, it gives you this. To make it neutral, if I remove the 3 electron away, I'll be having the number of proton to be equal to 33. This is another way to visualize this. If you don't understand this, take note of something that you can use this formula I have here, that the charge is equal to what? Is equal to the proton minus the electron. Take note of this formula. Yeah. The charge will be equal to proton minus electron. So let's go. What is the charge here? I have minus 3. What is the number of proton? I don't know. And what is the number of electron? That's 36. When I bring minus 36 to this side, I'll have 36 minus 3 equal to number of proton. Therefore, number of proton equal what? 33. You can be using this formula. It's very straightforward. The number of charge equal the number of what? Proton minus electron. And that is it. For the next question, a non-metallic ion Yn minus with an inert gas structure contains 18 electrons and 21 protons. What is the value of N? Now you have Yn minus and you were told that this has 18 electrons, the number of electrons equals to 18, and you have the number of protons to be equal to 21, and you're asked to find the value of N. Observe. Remember that what happens there, normally you have your number of proton. Remember, proton doesn't change, it is 21. And you are now having 18 electrons. What does that mean? It means that this Y has lost how many electrons? Check it out. It has lost what? 3 electrons. Check it out. Because if I add 3 to this, I'll have 21 electrons, which make it neutral. But it's not having 21, it's having 18. It means that it has lost what? 3 electrons. So it has lost what? 3 electrons. And that shows that what? N equal to 3. That shows that N is equal to what? Is equal to 3. That shows that what? N equal to 3. Another way to understand this is this. You can use your charge to be equal number of proton minus number of electron. And I have N to be the charge. Forget about the minus, don't worry. Equal, what is your proton? 21 minus what is your electron? 18. And that will give me what? 3. Then you put it there. So you have Y3 minus. So it means that what? It lost how many electrons? 3 electrons. And that is it. Next question. A monoatomic ion has a charge of this plus 1. The nucleus of the ion has a mass number of 144. The number of neutrons in the nucleus is 2.4 times that of the number of protons. How many electrons are in the ion? Okay, don't panic when you see questions like this. It's very straightforward. Let's see. We have a monoatomic ion. Let me say the monoatomic ion is X. And it has a charge of plus 1. So this is the charge I'll put in here. This is the charge of plus 1. And we were told that the nucleus of the ion has a mass of what? Has a mass of 144. And the mass is always be at the top, 144. And we're told that the number of neutrons is what? Is 2.4 times the number of protons. So let me write that somewhere. The number of what? The number of neutron N is equal to what? 2.4 times the number of proton. 2.4 times the number of what? The number of proton. This is what we have. Take note of this. And we have to find the number of electron. Don't panic at all. From here, you observe that we don't have the atomic number or the number of proton. We don't have it. And I would love to get this number of proton. Now, we all know that mass number is equal to number of protons plus number of neutrons. We know this already. Let us substitute. What is our mass number? 144. What is the number of proton? I don't know. Plus, what is my number of neutron? Check it out. We're told the number of neutron is 2.4 times the number of proton. So I have 2.4 proton. From here, what will I have here? See, 1p plus 2.4p, and that will give me 3.4p equal 144. So if I want to get my number of protons, I'll say 144 divided by 3.4. And that will give me 42 points something. So I'll just put that as a whole number. So to the nearest whole number, I'll have it to be what? To be 42. That's the number of proton. Now, how do we get the number of electron? Very easy. See, if proton is 42 here, what will be the electron? Remember, plus shows that it lost 1 electron. So I'll be having 42 minus 1, and that will give me what? 41 electrons. As simple as that. Next question. A monoatomic ion has a charge of minus 2. Let me now say, let the monoatomic ion here be Y. You can use anyone you want. Has a charge of what? Minus 2. So I'll say 2 minus. The nucleus of the ion has a mass number of what? 162. So this is the mass number. Let me put this as this is the charge 2 minus, and you have the mass number, which is 162. The number of neutrons in the nucleus is 2.2 times that of the proton. So you have the number of neutrons to be 2.2 times the number of protons. This is what you have. Keep it somewhere. Now, observe. We are asked to find the number of neutrons and protons in the ion. We don't know the proton. I write as P. And we all know this formula that mass number equal proton plus neutron. The mass number is 162. And number of proton I don't know. And number of neutron is 2.2 times the number of proton. What is 1 proton plus 2.2 proton? That will give me 3.2 proton equal 162. If I divide both sides by 3.2, I have 50.6, and that is approximately 51 protons. And I've gotten the number of proton here in the question. And what will be the number of neutron? To get the number of neutron, recall that from here, number of neutron is equals to 2.2 proton. And that's 2.2 times, I will not want to use this approximated value. I'll use what I have in this calculator, which is 50.625. And that will give me what? Times 2.2. That will give me the neutron number will be equal to 111 neutrons. As simple as that. That's very nice. So that's the end of the question. Now you can take this task. Your task is very simple. I can comment the answer. Can you tell me the number of protons, the number of electrons, and number of neutrons in the following species? The first one is, let me use another color for that. This is the first one. The second one, I have 127, 53, I minus. And the third one, I have 17, 8, O plus. And the fourth one, I have so work out this problem. And that's that about that. So thanks for watching. And if you are new to this channel, click on the subscribe button so you get notified whenever I release any new video. Thanks for watching, and make sure you practice the problem given in this video. Take care.